guys, so welcome to class today. We are going to warm up with a fluency activity called beep counting. So what's going to happen, so I say 1, 2, 3 beep, you say 4. Plain and simple. Sounds pretty, okay, I can do this, right? Yeah. So 10, 11, 12 beep. 13, good. All right. How about 20, 21, 22 beep. 23, good, okay. 1, 11, 21. Beep. 31. Excellent. Good. What about 30, 29, 28? Beep. 27. Good. 20, 19, 18. Beep. 17. Good job. 40, 30, 20. Beep. 10. Good job. You're doing great. You really are. 0, 10, 20. Beep. 30. How did I get to be the answer again? I don't know. Let's probably be like that number. Alright guys. So we're warmed up now. We are again today using tape diagrams to do using our read, draw, write. So read, draw, and label, write numbers and words. That's like the more laid out, but that's just a lot. So RDW, read, draw, write, is really read, draw, and label, write numbers and words. It's got a lot of pieces to it. So that does mean you don't have an application problem. Yay. Well, let me go ahead and tell you our problem type for today. Our problem type today is a missing part, meaning we have a part and we have the whole. We are missing a part, just like pictured here. We had a part, we had a whole, and then there's a question mark where the missing part will be. Now, some of these will be addition with a missing part, or they'll be subtraction because part plus missing part equals whole, and whole minus part is equal to missing part. So we're going to use both of those today, but that is our problem type. So yes, tape diagram still. We are doing missing part problems today. They can be found, this set of problems can be found in your homework I Want You to Succeed book on page number 83, front and back. We're going to do the whole homework assignment. I'm way too deep in the book. Struggling today. Turn the pages. Okay, here we go. Page 83. And just as a reminder, if you're needing additional support, the homework helper is here, and it's an excellent tool to show any of the grown-ups who are working with you so that they can better support you in utilizing the strategies we're working on. But this right here, Rose has 12 soccer practices, page number 83, right there. Rose has 12 soccer practices this month. 6 practices are in the afternoon, but the rest are in the morning. How many practices will be in the morning? Okay, let's read it again. This time we're going to stop when we get information. Rose has 12 soccer practices this month. Okay, that is our whole. That is our number of practices, because we're trying to find out how many will be in the morning. She has 12 practices this month. 6 practices are in the afternoon, and the rest are in the morning. So 6 practices are in the afternoon. So let's draw to represent 6 in the afternoon. 1, 2, 3, 4, 5. Yep, it's okay to recount. 6 in the afternoon. The rest are in the morning. So now my tape diagram matches what I know. So based on the way this problem is written, is this addition or subtraction? Correct. It is subtraction. Let's write our number sentence. So, 12 practices this month, taking away the 6 afternoon practice that we know about, leaves us with the unknown number of morning practices. That is the number sentence that matches this question. Do we have to solve it as subtraction? No, we can solve it by counting on from the known to the whole. So from 6, counting on until we get to 12, we will draw and see what our missing part is. So 6, 7, 8, 9, 10, 11, 12. Now we have counted on from the part we know to the whole. We can count up what is here in our missing part. Now tell me, how many practices did Rose have in the morning? 6. Rose has 6 practices in the morning. 12 minus 6 is equal to 6. 12 practices, 6 in the afternoon, the rest are in the morning, leaves us with 6 morning practices. So it's pretty fair. I mean, her practices were split in half between morning and afternoon. Makes sense to me. Yeah. All right. So like I said, we're going to have a missing part, and we may be adding and we may be subtracting. But we can utilize them together because they're like cousins. They're related. They go together. They're opposites. Related and connected opposites. They come from the same number bond. That's the big thing. These problems are each coming out of the same number bond. They're coming out of the same number bond. All right, so the next problem reads, Ben caught 16 fish. He put some back in the lake. He brought home 7 fish. How many fish did he put back in the lake? Okay, let's reread the problem, stopping when we see something that we can draw. Ben caught 16 fish. Okay, that's our whole. Good. So let's draw to represent our whole, or let's indicate that we know what our whole is. We know we need a tape diagram to represent our 16 fish. We know that step 1, Ben caught 16 fish. Check. He put some back in the lake. Some back in the lake. What is our symbol to represent some back in the lake for right now? Yes, it's a question mark because we don't know. He put some back in the lake, and he brought home 7 fish. So he put some back in the lake, and he brought home 7 fish. So we'll label this part home. Okay? So this part will be home. And what I'm actually going to do is I'm going to start drawing from the back so I know I have enough room. So let's count backwards. What's all I do? Yeah, I'll do that. 1, 2, 3, 4, 5, 6, 7. Home. Does this look like I'm going to have enough room to draw the rest of his fish? It does not. So what we're going to do is make this box, this part of the box, longer. Because we know that he brought home 7 fish, and we're trying to find out how many he put back in the lake. So what is the number sentence that matches this problem? Okay, yes. So 16 fish minus the ones put back in the lake is the 7 that he brought home. So 16 minus is equal to 7. 16 minus, I don't know, is equal to 7. That's what we need to find out. We need to find out how many fish went back into the lake. So we can subtract, we can count on, we can count back. There's any number of ways we can solve this problem. Let's count on, only we're going to draw backwards. Why are we drawing backwards? Because remember, we want to fill up that group of 10 so we can see what we're doing. So that was how many that he brought home? 7. Okay, so let's count on. 8, 9, 10, 11, 12, 13, 14, 15, 16. It doesn't matter which way you draw, as long as you put all the pieces there. Because remember, when we're adding and subtracting, it matters that we have all the pieces represented. So this time we started from the end because we knew the ending. We didn't know what happened. We knew the ending and we knew something happened, but we didn't know what happened. So by knowing the ending first, we drew showing that we knew the ending first. Now we can figure out how many fish he put back in the lake. And I'm just going to count how many are on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ben put 9 fish back in the lake. 16 fish caught minus 9 back in the lake equals 7 fish that go home with him. Now I'm done. Now I'm done. I have a labeled tape diagram, I have a number sentence, and I have a word answer. Is this the order in which did I solve the problem with the missing part? I did not. I did subtract. No, did I subtract or count or add? What would you say I did? I subtracted or I added? I added. I counted on. What I did was, instead of 16 minus 9 equals 7, what I did was, guys, I did this. I did 7 plus blank is equal to 16. And the reason I can do that is because both of these come from the same number bond. They both come from the same number bond. So I can rearrange my number sentence using what I know about the number bond. I flipped it and I counted on. I added to find the missing part. All right, let's do number 3. Number 3, I believe, puts you on the back side now. Number 3 reads, Nikhil solved 9 problems on the first sprint. He solved 11 problems on the second sprint. How many problems did he solve on the 2 sprints? Ooh. Well, what kind of problem is this? Oh, they snuck us one in there. So this is a part whole problem. So the first sprint, part A, he got 9. Part B, he got 11. We want to know how many problems in all he answered. So they just snuck us in one like yesterday's, which was a part plus a part is equal to a whole that we don't know. So let's draw and write and label to show what Nikhil did. Nikhil solved 9 problems on the first sprint. He solved 11 problems on the second sprint. How many problems did he solve on the 2 sprints? So let's draw a nice big old box. We're trying to figure out what he did here. This is what we're solving for. That's how many problems he answered. If it's 9 and 11, then my 2 parts are about what? They're about the same. They're about the same. Let's go ahead and about even split this. So, which part should I draw first though? His second sprint or his first sprint? His first sprint, because 11 is bigger than 9, and it'll allow us to draw in such a way that we can see 10 and maybe another 10, maybe some ones, but it allows us to make those groups of 10 easier because we're starting with the one that already includes a group of 10. That's that breaking apart, making pieces again. So let's draw. So the second sprint and the first sprint. Okay, the second sprint plus the first sprint is equal to the number of problems that he solved. So drawing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Second sprint 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's not that the boxes were that far off. What happened is when I color them in, for some reason I always draw them smaller. Now, the number sentence that matches this problem is that he solved 9 problems on the first sprint, and so 9 on the first sprint and 11 on the second sprint is equal to how many problems solved? Well, these are both almost groups of 10, aren't they? I can move these pieces around. Let's do that. Let's move these pieces around. You tell me, how many problems did Nikhil solve on his sprints? Look at how all of the pieces come together. All the pieces, everything we've been doing, builds on each other, works together. Correct. Nikhil solved 20 problems on the sprints. Nikhil solved 20 problems on the sprints. Let's go ahead and do the last one together, okay? This one says number 4. Alright, Shanika returned some books to the library. She had 16 books at first, and she still has 13 books left. How many books did she return to the library? So we're saying, we're starting with an unknown. We've been given what she had at first, which was the 16, and that she still has 13 books. How many books did she return to the library? So there's a couple number sentences that work with this. So blank books returned plus books left equals all of her books. Okay? Books at first minus books returned equals the books that she has left. Also true. You know what else is true? Books she had at first minus the books that she has left equals how many she returned. Is that all my number sentences for this number bond? No, I can also do books left plus books returned is equal to all the books. Good. Okay, either way, but no matter which one of these number sentences, though, matches the question. Whew. Okay, that's a little bit of a trick question because it is kind of written a little funny. The best match is this one right here. The number sentence that perfectly matches this question is actually blank is equal to 16 minus 13. And no, I didn't trick you because this number sentence is literally the same as that number sentence. It's just where did I put my missing information. So the missing part is equal to the whole minus the known part. This is technically the most matching, but this would be the one that is more familiar to you in terms of matching this problem. So the missing part on the side by itself is equal to the whole minus the other part. So let's go ahead and actually work out this problem. Alright, so she returned some books to the library. We don't know how many. We do know the whole. She returned some books to the library. We know she started with 16 books. She returned some to the library. And she has 13 books left. So she had 16 books. She returned some to the library. And she has 13 left. So because we know this part here, we know what we ended at, what she ended at, we're going to draw backwards again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that is the part of the books that she has left. We're now going to put the part we know in our head and count on, see how everything goes together, to the next part. So 13, 14, 15, 16. Now tell me, how many books did she return? 3. Good job. She returned 3 books. That's the missing part. So, Shanika, find a space to write it. Shanika returned 3 books. That's my complete sentence answer. That is my complete sentence answer. The part that is underlined, that is your minimum amount of information to be correct. If you cannot find the word Shanika and return, you need to have 3 N books or it is wrong. If your tape diagram is not labeled, it's not complete. But if you do not have your object and your number, then it's wrong. Because it's a word problem, and word problems require word answers. Okay, so let's look to see what it is we are responsible for today to complete independently. Let me dip my eraser. So what are you doing today? You're going to complete your problem set. Again, it's all word problems. That starts on page 125 in your Learn book. It is front and back. You're wanting to complete all 6 of the problems. Not the collective, oh no, again. Oh gosh, come on. Look. Problem set, read aloud. Learn book, pages 125. We talked about how that minus sign actually means through in this instance. 125 through 126. There's 6 problems. Oh look, 1, 2, 3, 4, 5, 6. When you clicked on the math assignment, you actually saw this first because you had to scroll down to get to where it said the Nearpod. So you came in, you did all this, you're here with me. I know it feels kind of surreal, it's live. You left out, you get time to do your problem set. Here is the read alouds for you. And don't forget your homework. This is still not homework. This is all classwork. This is all schoolwork. Okay? And then be sure to come back to the Nearpod so you can complete and submit your exit ticket. Modeling, still using that tape diagram to read and reread, draw and label, and write numbers and words to solve the problem, which will also be read aloud to you. But guys, that's all I have for you today. I think I covered everything. If I didn't, you know I want you to let me know. But I'll see you guys later. Bye.